Well, folks, you saw Dr. Ed, I said Mike by mistake, but Dr. Ed talk about the exact value of phi and how we get it. And I thought we'd just run through that again to give you an idea of how that takes place. So here we go with that. And as we approximated phi by calculating phi sub n plus 1 and divided it by the one before it, f sub n, for the larger values of n, we didn't find a pattern in the digits. So let's look at n, or let's look at another way of looking at f sub n plus 1 divided by f sub n and see if we can find a clue as to the exact value of phi and how you can get it. So as I said, I won't make you reproduce this for me, but however, I think you need to see this. I want to switch glasses real quick here. Give me a second. All right. Okay, sorry about that. So here we go. Let's have a look. You know that f2 divided by f1 is 1 over 1, or just 1. And you can take f sub 3 and divide it by f sub 2. That would be 2 divided by 1, which of course would be the same thing as 1 plus 1 over 1, right? 1 plus 1 over 1, okay? All right. You could do f4 divided by f3, which is 3 halves, which is 1 plus 1 half. Well, wait a minute. So let's see, 1 plus 1 half, well, that's not too exciting or too surprising, okay? However, remember, 1 half is the reciprocal of 2 over 1, right? So if you want to put 2 over 1 together, where this 2 is here, you could take this piece right here, 1 plus 1 over 1, and replace it where this 2 is right here. Okay, so that's what you're going to see next, okay, is 1 plus 1 over 1, this is 1 plus 1 half, sorry about that, or it's equal to the same thing as 1 over 2 over 1, and 2 over 1, as I said, is this. So that's how we get that expression. That's f4 divided by f3. All right, now let's go to the next one. f4 divided by f3 was this one, right, which we just saw. But notice that 2/3 right here is the same thing as 1 over 3 halves. Because it's the reciprocal of that, right? 1 over 3 halves becomes 2/3. So if we get the reciprocal of this, what will happen is that you will get, here's 3 halves, right? 1 over 1, 1 plus 1 over 1 plus 1 over 1. If we take this whole piece and put it down below here, which is in red, which shows 3 halves written that way. So again, notice we have everything written as all ones, and that's what Mike was talking about, or excuse me, what Ed was talking about in his video. So now if we leave that up here, okay, and now we go to 3/5, which is the same thing as 1 over 5/3, and 5/3 is the reciprocal of 3/5. And so we end up putting all of this, all right, down here, okay? All right? So, and we just keep going doing that. 1 over 5/3, you see there, right? Okay, and now it's 5/8, but we use 8/5, and we just end up putting these pieces below the other piece, all right? And we just continue to do that. And it just continues to grow and grow and grow as 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 to infinity, okay? And that's what Ed was showing you in the video. Now, you notice the thing in red, right? By the way, phi is supposed to be equal to this, right? So you see all this in red. Notice it's the same thing. If you look at it by itself, it's the same thing as we had back here, right there. That is exactly the same as that. So you just keep replacing it and replacing it and replacing it. So it's phi. So actually, the bottom down here is just another example of phi. So in other words, we take this right here, all of this, and we replace it for phi because it's equal to phi. And since that's what's on the bottom underneath the 1, we replace it with a phi. Now, I know that seems strange to you, but it works. Now, if I multiply this equation through, all right, by phi, okay, I multiply it through by phi, all right, I will get phi squared equals phi minus 1. Now, if you recall from high school, that smells a little like a quadratic equation, right? So let me go over here. It looks a little like a quadratic equation. So I'm going to bring the phi plus 1 over to the other side, okay? And when I do that, I get the same thing as phi squared minus phi minus 1 equals 0, which is the same thing as x squared minus x minus 1 equals 0. And if you use the quadratic formula to figure this out with a, b, and c, of course, the quadratic formula is a is 1, b is negative 1 here, c is negative 1 in there, okay? If you use the quadratic formula, which is this formula right here, putting a 1 in for a negative 1 in for b, and a negative 1 in for c, okay, you get this as a final answer. Phi is equal to 1 plus or minus the square root of 5 all over 2. Now, we don't want the negative value of phi up there, so we just use the positive value, the negative value of radical 5. Sorry, I said that wrong. So we just use the positive value. So it turns out that phi is equal to 1 plus the square root of 5 all over 2. And if you take a calculator, first take the square root of 5, add to it 1, take that answer and divide it by 2, you will get this answer right here to approximately 9 decimal places here. And this, of course, is called the golden ratio. And we stop right here and we round this 3 to a 4. So 6 decimal places, the approximation of phi is 1.618034. Now, on your test that I will probably give you on Friday, I want you to remember something, okay? I want you to remember the exact value of phi, which is right here. 1 plus the square root of 5 all over 2 is what we call the exact value of phi. This is the approximation, and I only want you to memorize it to 6 decimal places. But do you really need to memorize it? No, because if you memorize phi equals 1 plus the square root of 5 all over 2, you can work it out on your calculator, and you can figure out that it's 1.618034 rounded to 6 decimal places. Now, I always tease my students that I've had in Math 103, and I tell them 10 years from now, when I'm in my wheelchair rolling down the street, okay, and I stumble on you, and I say, hey, I had you for Math 103, and I will ask you a question. What is the exact value of the golden ratio? And I expect you to spit out 1 plus the square root of 5 all over 2. And I don't know if you'll be able to remember the approximation, but it is 1.618034. Okay, so I just kind of, not real well, but I kind of went through what you saw Ed go through to figure out the exact value of the golden ratio. Okay, so here it is. It is 1.618033989, or 34 rounded off, okay? And, of course, this thing's going to give me trouble, probably. So I'll just do this, if I can get off of it. And that is known as the golden ratio, okay? And you do not want to forget that, particularly before you end this course. You've got to remember what the golden ratio is. Okay. So having said all that, okay, I'm going to explain to you what your homework assignment is going to be for tonight, okay? It is to do group work number 7. Group work number 7. Also, I'm going to go back to it here for a second and talk to you about something on there that I want you to write down right now. And I just want you to complete those problems on group work number 7. And I'm also going to ask you to do the video quiz 7, okay? So you're going to have to look up the video quiz or print it, okay? It won't be on the video because I'm not going to show it on the video, but you're going to have to bring up that file on your computer. So the two things I'm going to ask you to complete for me this evening are going to be the video quiz 7 and also group worksheet 7. Now I'd like to go back to group worksheet number 7. I have it back here, so I'm going back to it right now. There it is right there. Now, if you would get group worksheet 7 out right now, I would like for you, please, to answer questions with me right now, 1, 2, and 3. What does this symbol represent? It's called phi, P-H-I, and it represents what? The golden ratio, right? Golden ratio. And what is the exact value of the golden ratio? You remember that phi is equal to 1 plus the square root of 5 all over 2. And correct to 6 decimal places, this is 1.618034. That will be a test question on your test coming up on Friday. So make sure you know it. Now, I'm asking you to complete the rest of group worksheet 7 for me, all right? And I will go over that with you first thing in our next class, okay? To make sure you have all that understanding that you need for the future and for the test. But what I'm going to do right now is I'm going to go on and discuss with you the stuff we're really going to talk about tomorrow. So I'm going ahead back to where I was. Okay, excuse me for making you sit through this process. Remember, what are factors of a number? Factors of a number, if you recall, are numbers that multiply, that have a partner, that give you a number in question. Like 25, for example. 2 factors of 25 are 5 and 5. They happen to be exactly the same, right? Okay. So, all right. Can there be other factors of 25? Yes, 1 and 25. Let's look at the number 12. 12 has a lot of factors and partners. 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and 12 and 1. Why did I write those down? Notice the factors actually shift at a certain point. And I'm going to come back and talk to you about that, particularly in our next class, about the factor shift that occurs in all the factors of a particular number, okay? But we'll just hold up on that idea for right now. Okay, so you know what factors are. They are multipliers. Remember, we are only dealing with natural or counting numbers. We are not dealing with any fractions or decimals, okay, when we're talking about this material. Okay. All right, you're to do video 7. You are to do video 7, remember, don't forget, not video 7, video quiz 7 for me tonight. And do video 7 group work tonight for me also. And so that's just a reminder to tell you that. Okay, there are the problems that are on the back, or excuse me, on the front of it. And we will discuss those again, like I said, tomorrow in our next class. Okay, and you are to do video quiz 7. Okay, we've already discussed what factors of a number are. They are numbers that multiply to give you a different number that's in question. Partner factors are the factor that is matched with the factor you have right now to give you the number in question. For example, 15, if I look at the factor 5, or excuse me, the factor 3, its partner factor is 5. So they are partners of each other. Most books don't talk about this. This is a Kellyism. I talk about it because I think it's helpful for you to understand this. Okay, so you know what partner factors are. Now it says review divisibility rules, do group work 8. Well, before I go to group work 8, okay, and I may save that for our next class, but I might not. If I decide to use it, I will have included it in the email. There are lots of divisibility rules out there that have been invented, or not invented, but discovered by mathematicians for years, okay? But there are only 3 rules that I want you to know. And you should know these the rest of your life. You should always know the following 3 rules, and they're very simple. First of all, I want you to think of, okay, counting numbers that are even, like 2, 4, 6, 8, 12, 16, 14, 18, 20, 22. Isn't it true that every even number you could ever think of that is a counting or natural number is divisible by 2? When you divide 2 into it, it will come out even. So the divisibility rule for 2 is very simple. If the number is an even number, it is definitely divisible by 2. And you know that. You've known that probably all your life. Now, the other real simple one to remember is when a number is divisible by 5. Well, let's count by 5s. 5, 10, 15, 20, 25, 30. Notice anything about those numbers? They all end in 5 or 0, don't they? And aren't all those numbers, when we count by 5s, don't we realize that all those numbers are divisible evenly by 5? For example, 5 goes into 36 times. 5's partner factor there is 6. 5's partner factor in 25 is 5. 5's partner factor in 20 is 4, and so forth. Okay, so if a number ends in 5 or it ends in 0, you know, and it's a counting or whole number, a counting or natural number, you know for sure it is divisible by 5. Now, the only other one that I want you to definitely know is the divisibility rule for 3. Now, what is the divisibility rule for 3? Well, let me give you a number. 121. I contend that you can tell whether or not 121 is divisible by 3. All you have to do is add its digits together. If you add 1 plus 2 plus 1 together, you get what? 4. Now, if 4 is divisible by 3 evenly, so is 121. Can you divide 3 evenly into 4? No, you cannot. So therefore, 121 is not divisible evenly by 3. How about 123? Is it divisible by 3? Let's see. 123, if you add its digits together, 1 plus 2 plus 3 equals 6. 6 is divisible by 3. It gives you 2, right? So guess what? 123 must also then be divisible by 3. And of course, if you divide 3 into 123, you'll see it goes 41 times. So those are the three divisibility rules that I want you to remember the rest of your life. You should always know them. There are other common divisibility rules that many teachers will ask you to memorize, maybe your children to memorize when they are in middle school, but those three you should know as an adult the rest of your life. It comes in very handy to know when a number is divisible by 2, by 3, and by 5. The rest of them we can just divide out on a calculator or on our phone to see if they're divisible into something evenly, okay? So there is the rules that you need to know for me. Divisibility rule for 2, divisibility rule for 3, and the divisibility rule for 5. Okay, now let's go on. Okay, we'll come back and talk about those divisibility rules again. Probably I'll wait until the next class to do that. It says here, find the prime factorization of these numbers. What the heck is the prime factorization of a number? Okay, well, let's start very easily here. A natural number has a prime factorization if it's composite. Now remember what we talked about prime and composite numbers in our last class. We talked about the fact that a prime number has as its factors only itself and 1, right? So if it's prime, all right, its only factors are itself and 1. If a number is composite, it is divisible by other numbers. Other numbers will go into it besides itself and 1. Itself and 1 will still go into it. However, okay, other numbers also will divide into it evenly. So if a number is prime, okay, it can only be divided by itself or 1. Now, this is kind of cool. If you take the number 1100, it can be written as the product of all prime numbers. Really? Yeah, it really can. You may recall of having done this in middle school, but we're going to review it. Now, you used to do this with what was called factor trees. With a factor tree, you used to draw this tree down below it and split them up like so. I don't believe in factor trees. I don't deal with those, okay? So if you want to do prime factorizations by factor trees, I don't have a problem with that, but I generally don't use factor trees to get the prime factorization of a number. What I do is what a friend of mine taught me to do, who was a math teacher I worked with for years, which is called successive division. What I do is I write the number I'm getting the prime factorization of down low. And I think of a prime number that will divide into it. Well, you notice we did the divisibility rules for 2, 3, and 5, right? 2, 3, and 5 are all prime numbers, aren't they? So they're probably numbers that we are hoping will go into some of these bigger numbers to make life easier for us here. Okay? Well, I think you can see that this number is divisible by 5 because it ends in a 0. So when you're looking to get the prime factorization of a number, all the numbers that are primes that multiply to give you the number in question, you always have to divide by primes. Okay? So let's see. The prime I'm going to divide by here is 5. So I'm going to do 5 divided into 1100. And when I do, I get 220. Now I'm done obtaining the prime factorization of 1100 if 220 is a prime number. Well, I don't think 220 is a prime number because it is divisible by what? it's divisible by 5 again, right? It's also divisible by 2, so you don't have to necessarily go in a specific order. You can go in any order that you're comfortable with by dividing by primes that go into it evenly. Well, let's see, how many times will 220 divide by 5? 220 divided by 5 is 44. Is 44 a prime number? Well, it's even, isn't it? Since it's even, it's divisible by 2. So I'm going to divide it by 2. And when I do, of course, I get 22. And now, of course, I could divide 22 by 2 also, right? 22 isn't prime. And I get 11. And of course, I think you are aware of the fact that 11 is a prime number. It has no other numbers that will divide into it evenly except 1 or 11. And please notice that if I put these in order, I would have 2 2s, 2 5s, and an 11. And those numbers make up the prime factorization of 1,100. Did I have to do it in the order I did it in? Could I have done it by first dividing by 2, and then dividing maybe by 11, and then dividing by 5? Yes, you can do it in a different order. So what I'm trying to do today is get you used to the concept of the fact that you can write any composite number, like 1100, as a product of prime numbers. And the number 1386 over here, why don't we go through that one also? If we take 1386 and write it down low, can you think of a prime that will go into that? Well, 2 will definitely go into it, right? Because it's even, right? So I take 2, 1386. 1386 divided by 2 is 693. Now, I don't know if 693 is prime or not. In our next class, we're going to be discussing methods that we can use to decide whether or not a number is prime or not, okay? Before we actually start dividing it by stuff, all right? But I'm going to save that for our discussion, which will be coming up in our next class, okay? Now, but I will give you a hint here. If you add 6, 9, and 3 together, you get 18, don't you? 18 has to be divisible by 3. So guess what? So is 693. So if I divide this by 3, I get 231. Gosh, is 231 prime or is it composite? Guess what? Add 2, 3, and 1 together, you get 6. 6 is divisible by 3. So guess what? 231 is divisible by 3. And I believe it goes 77 times. Now, 2, 3, or 5 will not divide into 77, will it? Okay, so I have to think of another prime, if there is one, that will go into 77. And I think you know that 7 will divide into 77, and it goes 11 times. So the prime factorization of 1386 is 2 times 3 times 3 times 7 times 11. You can write this with powers too. You could say 2 times 3 to the second times 7 times 11. Now you're saying, why are you asking us to revisit something we learned in middle school? Well, you know, you're going to get a real live job out there someplace where you're going to have a process that you have to follow to get something done where you work. And all I'm going to do is teach you information about getting prime factorizations of a number and determining whether or not a number is prime or composite ahead of time before you try to do it. It's going to be just like learning a new job and trying and finding out what the steps are that are involved to get something done. So I won't even test this material really on the final exam. I'm only going to test it on this next test, which you're going to take. So in the next class, I'm going to spend a lot of time talking about these things that I'm just now introducing to you, okay? So this process we are going to learn about, okay? All right, now let's go on. Let's see what comes up next here, okay? Let's go here. All right, well, I'm going to maybe save this concept about the factor shift for our next class because it will be used to help us determine whether or not a number is prime or composite, okay? So I think I'm going to save that for our next class, but what I would like to do is go here to group work 8, if I can find it here real quick. By the way, you see I have lists of prime numbers here for you to help you, figure out these answers here to these various problems, okay? So here's group worksheet 8, okay? And I think I'm going to go through group worksheet 8 with you today in this class, okay, so that we don't have to do it tomorrow. We'll get into more heavy-duty stuff tomorrow or in our next class, and we will definitely get into reviewing for what I'm going to expect you to know on our first major test, which you will take on Friday and over the weekend also. Okay, so now I'm not too concerned about these questions, all right, that are on the top. What I'm concerned about is what's down here. I want you to know these divisibility rules. So let's review those right now. And this chart is on the bottom of the sheet called Group Work 8. I am not assigning Group Work 8 for you to do this evening, all right? I only want you to do Group Work 7 and to do Video Quiz 7, okay? All right, now it says, show your use of the divisibility rules discussed in video 8, well, you didn't watch video 8, to determine if the following numbers are divisible by 2, 3, and 5. Okay, look at that first number. It ends in a 1, right? Since that first number ends in a 1, it isn't even, right? So is it divisible by 2? Absolutely not. So we'll put no, N. Look at the second column, the number at the top. Is that number divisible by 2? Well, it ends in a 0, right? 0, a number that ends in 0 is even. So yes, it is divisible by 2. All right? Look at the third number. Is it even? Yes, it ends in a 2, right? Therefore, it is divisible by 2. If you don't believe me, you could take each of those numbers and test them on your calculator by dividing them by 2. You'd find out the first one doesn't go in evenly. However, the next two do go in evenly, okay? All right, is the number divisible by 3? We're going to do the second row now. Let's see. Let's add up the ones in here. The 1 plus 2 plus 3 plus 4 plus 5 plus 6. Those ones, there are 6 of them. They add up to 6. Is 6 divisible by 3? It sure is. So is that number divisible by 3? Yes, it is. Okay, look at the second heading. 1 and 1. That adds up to 2. And 2 is not divisible evenly by 3. So this number is not divisible by 3. Look at the third number. If I add its digits together, 4 and 3 is 7, 2 and 1 added to it, 7 and 3 is 10, and 2 more is 12. Is 12 divisible by 3? Yes, it is. Therefore, then, that number is definitely divisible by 3. Okay. A number is divisible by 5 if its rightmost digit is 0 or 5, right? It says, right? It tells you the rules right there. And those are the rules, of course, I want you to know, okay, the rest of your life, okay? Now, is that first number divisible by 5? Does it end in 5 or 0? No, it does not. No good. How about the second number? Is it divisible by 5? Yes, it ends in a 0. So it is divisible by 5. And look at the last number. Is it divisible by 5? No, it is not. So that is a definite no. Okay, now you'll notice there is a back to group work sheet 8. And the back to group work sheet 8 is all prime factorization problems. You don't have to do those this evening. We will practice those in our class tomorrow, okay? And then we'll start reviewing also for the test probably. So just be aware of the fact I have basically covered everything I want to cover for today. So what is it I am asking you to complete for me tonight will be simply what? Group work 7 and video quiz 7. You can text me the answers you get to video quiz 7, and you can take a picture of group work 7 and send that to me so I can give you 10 points for having done it. Well, it was a pleasure working with you today. Hopefully the stuff we did with 1 plus 1 over 1 plus 1 over 1 plus 1 over 1, the golden ratio stuff was not too confusing. But hopefully you will remember that the exact value of the golden ratio is 1 plus square root of 5 all over 2, okay? And perhaps you will also memorize that it is equal to 1.618034 rounded to 6 decimal places. All right, good luck on the 2 sheets I've asked you to do, and I will be talking to you in our next class. You take care.